Hello, everyone. My name is Luis Hernandez.
I'm Jack Block.
I'm Valerie Lynch.
I'm Kaz Mankowski.
And we're here as part of Supermileage Systems Enterprise. In this meeting, we're going to talk about the overall introduction of the team, what we do as a team, the team progress, some of the updates on some of our projects currently, and some upcoming challenges as we approach for next year. So, Supermileage Systems Enterprise is a multidisciplinary student-led team that works on a fuel-efficient and lightweight car. We have participated in previous events as the Supermileage competition that we will currently have this summer in person. And in 2016, we participated on Shell Eco Marathon Americas. Last summer, due to COVID regulations, we had an issue, so everything in person got canceled. We participated in a virtual event where we placed second overall from overall 13 teams participating in the event. Our team structure is participating in a chain of command, as the CEO being the person that overall strategizes how the team is led and moves the direction of the team. He has help from all the other members, like COO and the CFO, which work with interpersonal connections within the team, as well as managing the budget and any purchases. We also have body, team, engine, and electrical, which manages specific components and projects for the car. We currently have 23 active members. Our current budget for this year is $13,000, and we ended up using $6,000 by the end of this date. We have about $600 left to use for the upcoming semester. Some of the goals and projects we want to work on for this upcoming year is to maintain the engagement on our overall team, make sure that our new members are involved in different projects, and then as well as improving our car as better as possible. These are some of the updates and some of the projects we're going to be working on this year. Body team, electrical team, and engine team have different projects of their own. The ones that have asterisks are the ones that we're going to be remarking in this presentation.
The first project we're going to talk about today is the Shell Redesign Senior Design, which I am on along with two other members of our team. Our objective is to design and create a plan for manufacturing an improved shell for a new generation of supermileage vehicle. Our goals are to brainstorm issues with the current shell, design a new shell in CAD software, and then validate this with finite element analysis, computational fluid dynamics, and physical material testing. We also plan to create a written manufacturing plan and documentation for the project, mainly a design report. We have some team-defined requirements for this. The new shell needs to be more lightweight than the existing shell and also have an improved aerodynamic profile. It needs to fit a 5'6" tall driver, have better seams on joined shell pieces, have a more horizontal driver position, and have better testing done, mainly FEA on the floor pan of the car to ensure minimal deflection. So this is a comparison of the new shell's CAD to the old shell. The new shell is in orange and the old shell is in pink. As you can see, the new shell is longer, but it also has a significant reduction in frontal area, which is much better for aerodynamics. With this CAD, we performed computational fluid dynamic simulations on it to see how the velocity of air around the car acts and where we have differences in pressure. Overall, we have very little eddy currents at the rear of the car, and we also have pretty consistent low pressure around the shell, which leads to a coefficient of 0.2 for the shell, which is very similar to the old shell. Overall, the new shell weight is about a 49% reduction, which is a very optimistic measurement as it doesn't take into account some mounting brackets in our windshield. We also reduced the frontal area by 25.5%. So even though our coefficient of drag does not change much, the frontal area reduction does result in a much lower drag force. For the rest of the semester, so this is the second semester senior design, so we'll be done after this. We need to finish up FEA on the floor pan, complete a manufacturing plan so the team knows what to do after we graduate, and finish up our final documentation.
Hi, I'm Jack Block, and I'm a member of the Steering and Driver Control Redesign Senior Design Project, where our main goal is to design a steering system for the up-and-coming shell, which reduces weight from our current steering system and also improves ergonomics. Some constraints that we have are that our steering system must be capable of turning within a certain radius. It must be able to, the brake system must be able to stop the vehicle within a certain distance, and it must fit within the new, longer, and slightly narrower shell design. For the driver controls, as I said earlier, there's a focus on ergonomics. We're including a burn prompter and electronic throttle indicator to allow for less successful projects attempted in the past to have the methods and to have the tools to be implemented and integrated more successfully in the future. We're also integrating an engine kill button to make it easier for the driver to stop the engine, a lap counter, as well as a brake sensor. Within the slide, you can see the design for our steering system, along with some finite element analysis for how the components would withstand loads. You can see from the finite element analysis that each component has a factor of safety of over 1. And you can also see that our driver interacts with the steering system through a direct connection to the wheel axle. Here is our current update for the design. You can see that the vehicle mounts, the vehicle axle, and the kingpins are all welded together. In the future, we just need to weld the brake mounts and to create the tie rod. Going forward, we need to assemble a test vehicle to ensure that the turning radius and the brakes are functional. We need to we also need to validate those requirements. We need to weld the steer arm and tie rod tabs to the assembly, as I said earlier, and to integrate the braking components.
For the rear subframe senior design, we are looking to design and manufacture a rear subframe assembly to mount the engine, drivetrain, and rear wheel within the vehicle designed by the new Shell Redesign senior design. Our drivetrain system is to connect the engine to the rear wheel, and some of our goals include like brainstorming different drivetrain options, create CAD of those different options, validate each option with FEA or fatigue analysis, and create a bill of materials and a manufacturing plan for future manufacturing. Some of our design objectives are components should fit within the new shell, as well as use lightweight materials for those different components, and every component should be easily removable, as well as the whole assembly should be very easily removable from the car, as to make manufacturing or modification easier on the actual car. Different drivetrain options that we've looked at are single chain and sprocket system, like the one that we currently use, a jack shaft that uses 2 systems of chain and sprockets, and then a solid drive shaft and bevel gears. The option that we picked is a double chain and sprocket with a jack shaft in between. The engine is centered in the vehicle to maintain weight, steadiness, and not create an offset due to an offset engine. 2 sets of chains transfer the force to the rear wheel with a jack shaft in between, like I said, in order to have the chain system and the rear wheel also in line with the engine. This would make the intake come from outside the vehicle instead of inside if the engine were to be offset. Some future work that we have is the FEA analysis to simulate the forces that are commonly exerted on all components and testing the factors of safety with each design option. Also, we need to complete a manufacturing process and a bill of materials in order to know what we have to make and manufacture next semester.
Thank you very much for watching.